solving simultaneous equations on graphs, for the most part, is not that complicated. Let's say you have two simultaneous equations which are, or a pair of simultaneous equations which are both straight line graphs. So y equals mx plus c for both of them. The solution is literally just where they intersect. So wherever that coordinate is, that's the solution. So similarly, let's say you have one part of your simultaneous which is a quadratic, another part of your simultaneous which is a straight line graph. Again, the points at which they intersect, you just have to read that coordinate on the graph. And then that's it, that's your solution. I don't want to go through that, just because it's fairly straightforward. I want to tackle the slightly harder questions. So for example, something like this. The line with the equation y equals 2x plus 1 meets the curve with the equation blah 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 at exactly 1 point. Given that k is a positive constant, find the value of k. Okay. My simultaneous is equation number 1 and equation number 2. Like this. Elimination in this case is going to be very difficult, almost impossible, because it's a quadratic. I have never done quadratic simultaneous using elimination. The only way I've ever done it is substitution, and that's the way that I would suggest doing it in this case. You have a substitute for y. So if you were to substitute y in, you get something like this. And now you can expand and make it equal to 0. So expand and simplify. Plus 4x plus 2 plus k minus 2 equals 0. Kx squared plus 4x plus k equals 0. Because plus 2 and minus 2 gives you 0. Okay. The key piece of information is they meet at exactly 1 point. So what can you use knowing that they meet at exactly 1 point? The discriminant. We've seen the discriminant before. We know that when it's greater than 0, 2 solutions, equal to 0, 1 solution, less than 0, no solutions. We've got our quadratic. We use b squared minus 4ac and we make it equal to 0. When we make it equal to 0 and we substitute our values in, we get something like this. So 16 minus 4k squared is equal to 0. So that means 16 equals 4k squared. So 16 over 4 equals k squared. 4 equals k squared. Root 4 equals k. So that means k can be plus 2 or k can be minus 2. Those are our two solutions. But in the question it says, given that k is a positive constant, which means that doesn't work. K has to be positive 2. Okay. It says, for this value of k, find the coordinates of the point of intersection. Right, so what we do is we take it from here, because that's when we've combined our simultaneous equations. We've worked out that k is equal to positive 2. So 2x squared plus 4x plus 2 equals 0. And now you just want to solve. So, can you solve that for me, please? Divide everything by 2. X squared plus 2x plus 1 equals 0. So x plus 1 equals 0, which means x minus 1 is your only solution. When x equals minus 1, you can sub that into equation 1. Y equals 2 times minus 1 plus 1, so y equals minus 1. So your final coordinate is minus 1, minus 1. Cool. Have a look at these questions for me, please. And I want you to give them a go. Okay, let's start with question 5. Find the coordinates of the points at which the line with the equation y equals x minus 4 intersects the curve with the equation y squared equals 2x squared minus 17. You're going to substitute y equals x minus 4 into y squared equals 2x squared minus 17. So I'll do that underneath here. X minus 4 all squared is equal to 2x squared minus 17. When you expand, you get this. Whoops. And then when you move everything to one side, you get that. And now you can factorize. X plus 11 and x minus 3 equals 0. X equals minus 11, x equals 3. And you're going to plug those into equation 1. When x equals minus 11, y equals minus 15. When x equals 3, y equals minus 1. So your two coordinates are that and that. Okay. Question 7a. Solve the simultaneous... Sorry, nope. That was me looking at question 8. Sorry. Determine the number of points of intersection for these pairs of simultaneous equations. Okay. They're both equal to y. So you're going to make them equal to each other. Or you can think of it as substitute equation 2 into equation 1. So 2x plus 8 equals 6x squared plus 3x minus 7. You want to rearrange so that everything is equal to 0. Like that. And now you're going to use the discriminant. B squared minus 4ac. Your a is 6, your b is 1, your c is minus 15. When you plug those values in, you get 361. 361 is greater than 0, which means you have 2 points of intersection. There you go. That's your answer. Okay. Question 8. Given the simultaneous equations, blah, 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 where k is a non-zero constant, that's super important, show that blah blah blah. Okay, let me do it here. So I can rearrange my equation 1 so that it's equal to y. And then that way, I have something that I can easily substitute in. So I can rearrange this as 2x equals 1 minus y. Sorry, 1 plus y, so 2x minus 1 equals y. That's what I'm going to substitute into this. So x squared plus 4k 2x minus 1 plus 5k equals 0. And now when I expand and simplify, I get 8kx minus 4k plus 5k equals 0. X squared plus 8kx plus k equals 0. There we go, that's part A done. I showed it. Given that blah 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 has equal roots, which means our discriminant is equal to 0, find the value of k. Okay, b squared minus 4ac equals 0. A is 1, b is 8, c is k. Substitute those in. 8k all squared minus 4 times 1 times k equals 0. 64k squared minus 4k equals 0. 4k, 16k minus 1 equals 0. That's just factorizing. So that means 4k equals 0, 16k minus 1 equals 0, k equals 0, or k equals 1 over 16. But remember, it says k is a non-zero constant. So this is your only solution. For this value of k, find the solution of the simultaneous equations. Take that value of k, put it in there. So for part C, you're going to have x squared plus 8 times 1 over 16x plus 1 over 16 equals 0. Times everything by 16, so you get rid of the fraction. Like this. And now factorize. 4x plus 1 all squared equals 0. So that means x equals minus a quarter is your only solution of x. When x equals minus a quarter, you plug that into your equation 1 and you get y equals minus 3 over 2. And there you go. That's your answer. Hopefully that made sense. If it didn't, watch that video back as many times as you'd like. Hopefully it makes sense after another watch.